Hi, in this video we're going to have a look at atomic absorption spectroscopy. I'm going to walk you through a basic overview, then I'll give you a bit of an analogy to help you understand what it is. We'll have a look at the explanation and then I'll talk about the benefits and the implications of using atomic absorption spectroscopy. So a basic overview. Atomic absorption spectroscopy is a very important technique that actually uses the absorption of light to measure the concentration of metal ions in very minute quantities. So it's atomic, so minute quantities, absorption, it uses the amount of light that has been absorbed. Spectroscopy, it looks at the spectrum. This was actually invented by an Australian scientist called Alan Walsh in 1952, who was working at CSIRO. And what happens is, in atomic absorption spectroscopy, I take a liquid sample of iron and I aspirate it through a plastic tube into hot flame so that the molecules now vaporize. As the molecules are vaporized, I take light and I shine it through this vaporized sample. What will happen is some of this light is going to be absorbed by the sample. So I have a detector on the other side that measures how much light is now coming through. And then based on how much light is coming through and how much light has been absorbed, I can determine how much material was there present in this sample. Now, just to walk you through the chemistry of this, we should know the atomic structure. So what we have is, we have the atom, and we have the nucleus, and then around that we have the electrons. Right? So the electrons are going around the nucleus. Now what I have is, they are in different energy levels. As they go up, the energy level increases. As they go down, the energy level decreases. When I shine light, light has energy. Alright? Light is made up of photons and light has energy. So what really happens is, when the light hits this guy, one of these electrons is going to absorb the light and jump back up. So what will happen is, when I look on the light on the other side, I'll see most of the light coming out with a few bits missing. And these are the bits that was actually absorbed by the electron to jump up. Now, based on the light that was absorbed, I can determine what type of element there is. Each element will absorb a particular type of light. So, and also, the greater the amount of the substance, the more light it will absorb as well. So based on this, I can determine how much substance there is and what it actually is. So, an analogy for AS is kind of like this, right? Supposing I have two people. I have Bob and I have Jane. Right? Now I know that Bob likes Mars bars and Jane likes Snickers. And I have a room. And I do not know who's in the room. Alright? So what I do is, I make a conveyor belt and I put Mars bars and I put Snickers and Mars bars and Snickers and Mars bars and Snickers. Alright? And I put it through. And I look at what's coming on the other side. Now if I only see Mars bars coming out and the Snickers have actually been eaten up. So the Snickers have been eaten up. I know that actually there's Jane in this room. Similarly, if I put this in and I see that the Mars bars are actually getting eaten up and the Snickers are still there, I know there's Bob. This is essentially the same principle that we use for AS. I shine light through. Light is made up of different frequencies. So the element inside will absorb particular frequencies of light. And then when I look at on this side and look at which of the frequencies are missing, I can determine who was inside this. So the basic steps of AS are this. Let me just clear that out. Now, as I said, it all depends on light. So what I actually do is the simplified diagram. I have a lamp that produces light. Then what I need to do is I need to vaporize the substance. So this is fire. I vaporize the substance. I put it through a monochromator. Alright, and then I put it through a photomultiplier. And then finally, what I actually do is I have a readout over here. So here's my sample. Goes through here, goes through there, goes through there. Now the steps for this is basically this. I need to pick a particular type of light because, like I said, I need to determine. I'm trying to figure out between Bob and Jane, so I should use Mars bars and Snickers, and I don't really care about M&Ms or any of these other stuff. So similarly, I have to pick a particular type of light that I want to use. Then what they actually do is they take the sample and they aspirate it, which essentially means I need to vaporize it, because if it's not vaporized, it's not going to absorb the light. Then it actually comes through the monochromata, which selects a particular frequency of light. I then put it through the photomultiplier, which needs to increase it's going to amplify the signal so that I can get a better reading, and then I have a readout on the other side that I can actually use. Now the thing to keep in mind with this is AS only gives you an absorption reading. It does not actually tell you the concentration of the substance directly, it only gives you an absorption reading. So the analogy for this is kind of like, it will tell you that 3 Mars bars were missing, or 4 Mars bars were missing. Alright? It won't tell you how many Bobs or Janes was actually present there. So if you know that each Bob eats 2 Mars bars, and there's 4 Mars bars missing, then you know that there were actually 2 Bobs in the room. So that's what you need to do. You need to calibrate this. So one of the things you need to do before this thing can actually work is you take sample of known concentrations, you put it through the AS machine, you find out how much it has been absorbed, and then you know how much does each element absorb, how much light does each element absorb. And then once you have that, you can figure out how much light has been absorbed and work backwards to find out how much of a substance was actually in there. Now, one of the really good things about AS is the fact that it can not only tell you if something is present or not, it can also tell you the concentration of something. As I said, it will tell you there's 4 Mars bars missing, and you know that each person has 2 Mars bars, so obviously there are 2 people inside the room. And it can actually work for very, very small concentrations. It works at parts per million. So even though you might have 2 Bobs for a population of 100 million, you can still find that there's actually 2 Bobs inside, because the 2 Bobs will chew the 2 Mars bars no matter what. So it's a very, very accurate technique, and it can measure concentrations in parts per million. That's all we'll have a look at today. I hope you enjoyed that. Thank you.